Let's briefly review power. Power is the rate at which work is done or energy is consumed. And last time we went over three variations of the equation for power: work divided by time, force times distance divided by time, or force times speed. Let's do another power example. Actually, in this lesson we're going to do this example twice. Once we're going to do it with just variables until the very last step, and in the next case we'll put the numbers in right from the get-go and look at it from a slightly different angle. So here we have a rocket of a certain mass, and it accelerates upward from rest to 540 meters per second in 2 minutes 46 seconds. Over here on the right, I'm writing down the variables that we know. We know the mass, we know the initial speed to be 0 because it starts from rest, we know the final speed to be 540 meters per second, we know the time, we know the air resistance as this rocket travels upwards, and we're asked to find the average power of the rocket engine. So let's draw a free body diagram of this rocket. Air resistance opposes the motion of the rocket. The weight of the rocket, of course, acts straight downward. And what I'm just going to call the force from the engine propelling it upwards. Sum the forces. If I pick upward to be positive, the force from the engine should be positive minus the air resistance minus the weight, and by Newton's second law, those summed forces should add up to be the mass times the acceleration. By definition, the acceleration is the change in velocity over change in time, and we know the final and the initial velocity and the time, so that quantity is known. What I'm going to do now is solve this equation for the force for the engine. I'm going to take the air resistance and I'm going to put that on the other side where it becomes positive, and I'm going to take mg and I'm going to put it on the right side where it becomes positive so that I get this expression. I'll go ahead now and factor out an m from the two terms that I can factor an m out of, and then the power is equal to the force times the speed. That was one of the equations for power that we talked about last time. I'm going to go ahead and put in square brackets the engine force, and then on the outside I'm going to carry down this average speed. Well, the average speed, if you look on the far right side here, the average speed is 270 because we started at 0 and we ended at 540. So the average is 270. All of these other variables we know. There's the mass of the rocket. The change in velocity is v final minus v initial, which is 540, minus 0, which is clearly 540. The amount of time in seconds is 166. There's g, we're going to assume we're on Earth, and there's the air resistance. You type all that in, you get 2.2 times 10 to the 6th watts, which is 2.2 megawatts. Let's try the same problem, but now we'll write down the numbers right from the beginning. We have our 500 kilogram rocket. It starts from rest and it ends at 540 meters per second. The time is 2 minutes 46 seconds. Of course, 1 minute is 60 seconds, so 2 minutes would be 120 seconds. So 120 seconds plus another 46 is 166. The air resistance is 1500 newtons, and we want to find the average power. So let's draw a free body diagram of this rocket. There's the air resistance, 1500 newtons. The weight, m times g, so that's going to be 500 times 9.81, which is 4905. And then we have the force from the engine. The net force on the rocket, according to Newton's second law, should equal the mass of the rocket times its acceleration. The acceleration, by definition, is change in velocity over change in time. Those quantities we know, and we should be able to calculate the net force on this rocket, 1626.5 newtons. But if we look at this free body diagram, those are the only forces that are acting on this rocket. In other words, the sum of these must equal 1626.5. Let's go ahead and write that out. The net force on this rocket should be the force from the engine upward minus 1500 minus 4905, and that should equal the net force. But this left side of the equation we just calculated. So I'm going to go ahead and change that to 1626.5, which means we can calculate the force exerted on the rocket due to the engine. One equation for power is that it's force times velocity. There's our force. Our average velocity is 270 because we started at 0 and ended at 540, so the average is 270. And sure enough, we get the same power for the engine as we did last time.